So with the exponential functions that we've been looking at, we're going to look at the word problems, and there's two equations that we need to talk about. Okay? This one, it says a equals p times 1 plus r to the t. T is a power there. This one is the most common equation that you'll use. And then this equation, it says a equals p, 1 plus r over n raised to the nt. N and t are both powers. So n and t are like multiplied together and then become the power. Both of these questions, you're going to see the word compounded. But this one right here is the one that it's going to say compounded a certain way. The top one, it might say it does this percentage each year, or it might say compounded each year, or something like that. But the second equation is going to say compounded and something about an amount of time. It might say monthly, it might say quarterly, it might say semi-annually, it might say daily. It's going to say compounded and then a certain amount of time. That's how you know to use this equation. If you don't see compounded and then some kind of time, then you're going to use this first equation. If you see compounded and the time is just once a year or yearly or annually or a percentage, that's when you use the first one. But when you see compounded monthly, quarterly, semi-annually, that's when you use the second equation. Okay? A is the amount after whatever time the problem talks about. The problem might say, how much is going to be there after 10 years? The problem might say, how much will the car be worth after 5 years? It might say how much bacteria is there after a certain amount of time. Okay? That's what A is. And on these questions, that's what you're looking for. P is your initial value, or your starting value. Sometimes it's also called the principal. The principal is the initial value or the beginning amount. Okay? Different from the principal of the school, but it does represent the amount that you start with. T represents the time. And in most cases, it'll tell you that we're looking at the time after 5 months, or we're looking at the time after 20 years. So you just have to read the problem and figure out where that time comes into play. R is your rate. When you put your rate into the equation, you have to divide by 100 or move decimal to the left. I'll show you what that means when we do some examples, but basically what that means is you can't put a percentage into an equation. You have to change the percentage to a decimal, which really just means divide it by 100 or move the decimal over to the left 2 places. N is the amount of time per year. And N is not in every question that you'll see. N only comes into play when you have the second equation that you have to look at. Okay? Annually means that N is 1. And that makes sense that if N is 1, you get that original equation, so you don't have to use that second equation. Monthly. When you think about monthly, you think, okay, how many months are there in a year? Well, there's 12 of them. So N would be 12. Quarterly. If you think about separating the year into quarters, you're separating it into 4 different parts. It's every 3 months, but you're separating it into 4 parts, just like 4 quarters make $1. Okay? And so in that case, that means that there are 4 quarters per year. Semi-annually means every half of a year or every 6 months. So that means that that would be 2 times per year. That's the most common ones that you could see. I mean, it could say weekly and it could say daily and that kind of thing, but this is the ones that you would see most commonly. So looking at the word problems, the first thing you want to do is read it through, figure out if it says compounded in a certain amount of time, figure out what equation to use, and then determine what all your values are and where it goes into the equation. Okay? So the first one says the value of gold grows by 1.5% per year. This is going to have to be R because that's a percentage. I can just already tell that. If you buy a piece worth 162, that's probably the principal, the starting amount. How much will it be worth in 20 years? That's going to be your T. I don't see anything telling me monthly, daily, semi-annually, so that means I'm going to use that first equation. Okay? So I'm going to use A equals P times 1 plus R to the T. You do need to keep in mind when you're doing these problems, this one says it grows by 15 or 1.5%. If it said it decreased or decayed, you would have to put a negative where the R is. Keep that in mind. I'll show you that in a little bit, but it grows, so we're good. And then we just need to put our the numbers that it gives me in the right places. So we're looking for A. P is 162. R, okay, so it's 1.5%. So either divide that by 100 or take the decimal and move it 2 places. When you move it 2 places, you would get 0.015. And then 20 years would be the T. And then from there, we just solve it. And you can use Desmos to solve it, or, a calculator. I like Desmos because you can see it all at once, and you can see how it raises to the power. Some of you like using your phone, but the power is a little bit confusing on your phone, so I really like looking at it in Desmos. 1 plus 0.015. You don't put the percentage in there or anything. You have to change it. And then just a reminder, this A to the B button is where you get your power. And you put 20. And so it looks like after 20 years, you get $218.19, which is not a lot of an increase after 20 years. But basically it's because that percentage was a very small percentage that it was growing by. Number 2 says you will buy a car for $12,500 today. The value of the car depreciates, that right there is really important, depreciates at a rate of 5% each year. What will the car be worth in 10 years? Okay, so if I'm buying a car for $12,500, that's not going to be my starting value because that's the starting amount I'm going to pay for it. And so that's P. I see that 5%, so I know that's going to be a rate. I am going to go ahead and move that decimal over. Whenever you think about it, the decimal's right behind the 5. So if I move it over, I get 0.05. And remember, if you'd rather divide by 100, that's okay too. The other thing in the problem is that 10. That represents the time. In this problem, again, I don't see anything that says anything like compounded a certain way. So I know I'm just going to use that first equation. If it helps you to write it so you can start memorizing it, then you should do that. But anyway, we're looking for A. The P is 12,500. The R is 0.05. The time is 10. I did something wrong. You know what it was? Depreciates. If you see depreciates or decays or decreases, that has to be a negative. So, let's put that in Desmos. $12,500. 1 minus 0.05. Raised to the 10th. Remember, A to the B will put that power up in for you. And you get 7,484. So after 10 years, it's almost half of what it was worth. And that's what happens with cars. They decrease so fast. Okay, so again, this problem doesn't talk about compounding any kind of way. So now I'm going to use that first equation. So A equals P. So P is the starting value. That's the 7,500 bacteria cells that you start with. They're increasing by 25% per hour, so that's 1 plus because it's increasing 25%. So I'm going to move my decimal over 2 places from the 5. It's always behind it unless you see a decimal. So that's 0.25. How many cells would there be after an additional 4 hours? So that's raised to 4. Keep in mind that it says per hour here when it talks about the percentage. So when it wants to know about 4 more hours, I still have to be in hours. As long as the percentage is in hours and the time is in the hours, we're good and we can keep it the same. Okay? So then we would just put that in to figure out what our final answer would be. 7,500, 1 plus 0.25 raised to the 4. And that's a whole lot of cells after 4 hours. I usually round it to 2 decimal places if you have a question about how much to round it to. I'm probably going to, be pretty lenient about it as long as I can see your equation and know where you got it from. But that's a lot. If you think about 4 hours going from 7,500 to there, hopefully you're getting an idea of those percentages and if the percentage means that that would be a lot or not. Like this 5% wasn't a whole lot, but it was 10 years, so that's why it seemed more. This one was such a small percentage, 1.5%. This was a pretty big percentage, 25%. Even if you think about clothes in a store, like whenever they're on sale, and trying to decide, is that really a good percentage rate that they're counting it off on? 25% and higher is usually a pretty good sale. And if it's only 5%, not a lot. So that's kind of giving you an idea about what those percentages mean. Okay, let's look at number 4. Number 4, it talks about a deposit of $4,000 into an account paying 6% annual interest, compounded quarterly. Right there, those are the important words to help us know that we're going to use a different equation here because I see compounded quarterly. And how much money will that be in 5 years? So in this problem, we're going to use that other equation because it says compounded quarterly. So I need to make sure I know what P is, what R is, what N is, and what T is. And so the amount that you start with, that's the P, that's the amount you deposited. Your 6% is your R, but again, think about moving that decimal over. It's behind the 6, so if I move it over, it's 0.06. The 5 years is the T, and the only thing we haven't talked about is N, but when you see what it's compounded like, that tells you what N is. So N is 4 because it's compounded quarterly. So, putting it into the equation, we're going to have A equals 4,000, 1 plus R, which is 0.06, over N, raised to the NT. NT means multiply N and T together. So basically it means 4 times 5. It is a little bit tricky in Desmos to put that in Desmos because you have to put that 4 times 5 in parentheses to keep it in the power. And I'll show you what I mean there. So we've got 4,000, 1 plus 0.06 divided by 4. Make sure you're outside the parentheses. And when you raise it, if you just put 4 times 5, look what it does. It puts that times 5 down at the bottom. Okay? So if you put anything other than just one number, you got to be, it won't do it correctly. But if you put a parentheses and then 4 times 5, not divided, it will keep it up there as long as that parentheses is up there. if you know what 4 times 5 is, you absolutely can put that in there. Sometimes it's bigger numbers and stuff, so you might not want to, but you absolutely can put 20 up there if that is easier, not have to remember that parentheses. In this case, after 5 years, you get $5,387.42. Again, it doesn't seem like a whole lot of money after 5 years, but really, it is. I mean, that's $1,000 that you didn't do anything for, that you just let sit in an account and grow. And so, kind of nice, especially if you can research to find out the best way to get that percentage. Okay. Okay, let's see what we got. Alright, I still see compounded monthly here. So I know I'm still going to use that same equation that has the ends in it. 6,500 is the initial amount. That's the amount you start with. 1 plus rate is 8%, so I know that's 0.08 when I move that decimal over. Compounded monthly, so that means I'm going to divide by 12. And then I'm going to raise it to the NT, so that would be 12 times 7. So if I'm putting that one in, I would have 6,500 times 1 plus 0.08 divided by 12. Again, if we know what that equals, we can put it in there. Or as long as we put a parentheses, it will multiply for us. And we get 11,358.24. Again, I usually just round to 2 places. A lot of times we're talking about money, so it makes sense to round to that decimal. Okay, let's look at number 6. The population of a popular town of Smithville in 2003 was estimated to be 35,000 people, with an annual rate of increase about 2.4%. Write an equation to model the population, and use your equation to estimate the population in 2007. So this one was interesting because they didn't say how many years. However, they told you that 2003 was when it started, and we want to estimate it in 2007. You may have to subtract to figure out how many years it is for what you want. So that right there tells me that T is going to be 4, because it's 4 years since 2003. This question asks you to do 2 things. It says write an equation and then estimate. Well, we've been writing equations. When we put the information on paper, what we're going to put in Desmos, that is the equation. So that's not really any different from what it's asking. You just may not have known that. So our population is going to be whatever we started with, which in 2003 was 35,000 people. 1 plus, by the way, it doesn't say compounded a certain way. So we're not going to use the long equation. We don't have to have n. Our rate is 2.4%. Move that decimal over. In front of the 2 is 1 place, and then 1 more makes a 0, so 0.024. And we said it was 4 years because from 2003 to 2007, that's 4 years. So we would just put, that's the equation that it's asking for when it says write an equation. And then when we put it into Desmos, that will give us our answer. And so our population was 38,482.91. Again, I always just do 2 places, but really we know that we're talking about people here, so probably 1 less than that. Okay, so on 7, it tells me, again, there's that compounded monthly, so I know I'm going to use the longer equation. 300 is the amount that you start with, and our rate is 5%, so it's 0.05. You divide that by whatever it's compounded by, which is the 12. And then you raise that to NT, so N is 12 and T is 20. And so you just put your information just like that. So 300 times 1 plus 0.05 divided by 12 raised 2. And I'm going to put that 12 times 20 in parentheses, unless you want to find out beforehand how much it is. And that gives you 813.92. 0.79, which after 20 years is not a lot of amount of money, but again, it's still money that you didn't do anything for. So, all right, and then let's talk about the car. So this one, we buy a car at $25,000. No compounded, so no in there. Depreciates means we have to subtract it. And it would, like, if you get something bigger, you know that you have forgotten that subtracted. So just think about your answer when you get it. Your rate is 15%, so I know that's 0.15. No in because we're not compounded it. And we want to see how much it's going to be worth in 10 years, so we just raise it to the 10. 25,000. 1 minus 0.15 raised to the 10th. And this is where it's disheartening a little bit because cars decrease in value so much. Unless you have a really old car, and a really old car will increase in value. But cars depreciate quite a bit. So, any questions?